And then here I have my little summarizer. And then we paste in the link, hit submit. So on the right side, I have the logging pulled up. So you can see that it's doing download first, and then now it's like trying to transcribe it. And this is calling out like the Whisper C++. And now we play the waiting game.
5 minutes later.
Why is this taking so long?
3 days later.
Wait, shit, did something happen? Hey guys, welcome back to the channel. So sometimes I find myself listening to these hour-long podcasts only to forget the key takeaways after. Let's build an LLM app to fix that. Our goal is pretty simple. So from a podcast MP3 file, we want to transcribe and transform it into a summary of the important highlight chapters. Let's take a look at the architecture that we're gonna build. So starting with the user, we're gonna have a UI and API, pretty straightforward. And then after that, for the LLM part, there are two components. So one is the transcription. So we want to go from an MP3 file to a text file. And we're going to do this with Whispercpp, which is a high performance implementation of OpenAI's Whisper speech recognition model. And we'll do this part locally. Now for the LLM backend, there's a ton of options, but there are two criteria that we really care about. How much it costs and the context window. Money, because we're very cheap. And the benefit of a large context window is that we can just shove the entire thing into the LLM instead of having to chop it into multiple parts. So the free tier of Gemini 1.5 Flash kind of checks both boxes for us. For the context window, it has 1 million tokens, which is ginormous. And you can see here, like a normal podcast of like an hour is only a fraction of that. And on the money side, so it's free up to 1 million tokens per minute and 1,500 requests per day. So we're good. Yo, Guang, I thought this was the coding channel. You're right, let's get into the coding. All right, so our first step is to set up Whisper C++. I've already downloaded here, so we just gotta point to the executable and the model. Next, we're going to download the podcast. So here, I'm just setting up the directory and then giving it a file name. And here, we're gonna check if the file path already exists. If it does, we'll just directly transcribe it. We don't have to download it again. Okay, so this part is a bit weird. So we have to basically fake our request to get around redirects, because we're using listen notes as our source for getting these MP3 files. Okay, so now, yeah, we have the URL and then we have a temporary file path. So we're just using requests to get the URL and then writing it down to the file path. Okay, now that we are able to download the podcast from a URL down to our local disk, we're going to actually try to transcribe it now. So first thing we do is we initialize a transcript file path that we're going to write to. Okay, so some bad news bears. Whisper C++ does not have a Python binding, so we gotta make an ugly ass subprocess call. What's worse, the input has to be a WAV file, but we usually get MP3s. So our first step is actually to convert it. Luckily, we can do this with audio segment from PyDub. Okay, now we can try to do the subprocess call to the actual Whisper C++. Here are some just default settings I'm using. Because it's a subprocess call, we need to capture the standard out and the standard error. And then we're going to get them out and make sure they look fine. And then finally, we save it to our transcript path. All right, before moving forward, let's actually make a little test and to make sure this shit actually works. So here's a pretty simple test. Based on a URL, we're gonna generate a random ID and then we're gonna shove it in to see if we, and then we'll actually check to see if it exists, and then we'll actually open it to see what's about. And then we'll actually open it to see if it worked. Okay, so let's find an actual podcast. So we're gonna use the intro episode for our little podcast. So we're gonna here download the address. So the link looks weird, but it actually redirects to a MP3 file, as you can see here. All right, let's run the test, see what happens. Cool. Let's actually look at the data to make sure it looks fine. Okay, that looks pretty good. All right, now that we're done with the part 1 of doing the transcription, we can move on to the summarization part. We're people of culture, so we're going to use the Instructor package, which basically forces pedantic models onto the response objects, such that we can have a lot more sanity around what outputs we get out of these LLMs. Okay, so first let's initialize the Gemini LLM, and we're wrapping around the instructor, and then we're going to define what the outputs will look like. So we want a list of segments. These have 4 components, so the title, description, the direct quote, and a timestamp. So here we're going to use description to kind of to give a little bit more requirement to the LLM in terms of what we want. So we have the LLM initialized, and we defined what the outputs should be. Here you see the response and the response model, and we want a list of segments, not just one segment. So we now give it the normal LLM prompts, so for the system and then for the user. For the system, it's pretty straightforward, just like, hey, please analyze and extract insights. And then for the user prompt, it's a little bit more involved. We want to get a title that's interesting, brief description, and the direct quote that captures the essence of the segment. Okay, now at the very end, we can basically open up the text file transcript that we have already made and feed it through this function that we just created, which is called summarize. And now we should get the segments. Okay, just like before, let's write a test to make sure this thing kind of works. So here I'm just importing the summarize on transcript, and here I made a helper function that basically pretty prints the result pedantic object. And here I made a test transcript file, put in the same directory as the tests, and which I just put a longer podcast transcript. And let's see if it works. Sweet, looks like we're getting the output in the format that we want. Nice. All right, now we're done with the LLM part, so the summarization and the transcription. And now let's write a little API that wraps these two things. So for the API, we're going to use Fast API. I just started trying it. I like it over Flask because the schema to the data structure mapping is pretty nice. So here we're starting with the boilerplate, and all we really need are 2 routes. So one is to do the transcription, and then after that, we're going to make a separate call to do the summarization. So the interesting here is that we need to predefine what our data structure looks like. So we're going to over here make a schema file, and then basically say what they are. So for the first part, we're just getting a episode internal ID, which is a string. And then for the second part, the final result, it's a segment of these 4 fields that we've already pre-established. In fact, this is the same pedantic model that gets used in the summarization step. All right, let's do the transcribe step first. Pretty straightforward. We just use the URL, feed it in, and then we get the internal ID that we can refer to it by. Similarly, for the summarize step, we're just calling the function that we made, summarize on transcript. We give it the internal ID, and then we should get out this list of segments. Okay, so before we go on to the UI, let's test it to make sure this is good. So let's try transcribe first. Let's give it the URL here we've used before, and let's see if we get out the same unique ID. Sweet. Now to test summarize, let's use the same ID to see if we get out those segments. Awesome possum. So now we have everything we need. Let's go work on the UI next. Okay, so for UI, if you're trying to learn how Next.js works, you're definitely in the wrong place. Clown face emoji. But if you're into the whole blind leading the blind thing, then here's a quick walkthrough of how I got Claude to code half of this for me. My understanding of it is basically for this homepage, we can change the text to have a simple landing thing. And then we built this URL input button, which holds most of our logic. So in the URL input button, we need to create a handler to handle the events, and then have a segment object to transport the data. And then we're going to call transcribe and then summarize. And for each, we're going to use a wait because these are sequential. And after getting the final summarized data, we're going to then try to display it by returning this whole mess here that has the formatting of all the different sections that we want to have. All right, so everything is set up and ready to go. Hashtag famous last words. I'm going to do a quick demo for my buddy Austin. Okay, so let's see it. Okay, so if we pick a podcast, and then here I'm just copying the link. So here you can see this will redirect to like a MP3 file. And then here I have my little summarizer. And then we paste in the link, hit submit. So on the right side, I have the logging pulled up. So you can see that it's doing download first, and then now it's like trying to transcribe it. And this is calling out like the Whisper C++. And now we play the waiting game. So I have like a M1 Max. So it does run, I think, about like 4 minutes to do it.
Oh, okay. So this runs local, right?
Yeah. So this is a part that's like quite slow.
Okay.
Why is this taking so long?
I do wonder if it's because you're doing the recording as well. I'm wondering if that's slowing it down too.
Yeah, I only did the test with a small file. I probably should have done it on a large file, because now I'm realizing maybe it's doing timeouts or something. Okay, so let's do some. No, it's doing stuff. Wait, shit. Did something happen? Oh yeah. So that was all the logs that got dumped from the transcription.
Oh,
So, now it's done. So the thing is really fast for the for the Gemini part of sending it to the LLM. It takes I think under like
okay.
a minute. So the waiting is more from the Whisper. All right. So so let's look at the results. So it's broken up by these like chapters.
Right.
You have the timestamp to kind of go along with it. It's ordered by the time. Okay, it is not. Okay, I should fix that. I thought I had fixed that. Oh, this is this is looking very questionable. Sorry.
What is the timestamp?
So I'm supposed to grab like where the kind of the chapter starts with that timestamp, or sorry, of the quote specifically.
Okay.
Yeah, but then
And that's it.
I think it's
Okay.
mixing things now a bit.
Okay.
Yukes.
That's in hours though, right? I'm not reading it incorrectly.
Yeah, so hour, minute, and then seconds.
Okay.
Yeah. One thing I thought it was interesting during the so also the chapter 1, because we do this highlight, which then gets copied again later. It's like a highlight from the actual podcast. So then I think that's how he got confused of like, oh, this happened later on. So you grab like the timestamp of the later on one.
Oh, okay.
Yeah. This largely looks reasonable, but one interesting thing was like I didn't ask it for specific, like the prompt. I didn't ask specifically like, oh, how many segments there are, or like give me like 10 chapters, or I just give it like just give me chapters, and it's pretty good about like determining, oh yeah, like this is like worthy of like being a chapter. So like for example, when I was testing it on smaller data sets, it would give like maybe only like 2 or 3 because it's only like 5 minutes or 10 minutes long. So I thought that was kind of nice to have that. But I guess the issue here though is like there's a big gap between like say the 14 to like 55. So like ideally I want to have something filled in. And then you see also, yeah, like a cluster of like these different timestamps.
You could have like a timeline. I think that would be nice, kind of like on YouTube.
That was the
So you kind of know where the.
Well, are you talking about like having like a literal timeline, like a visual thing at the top?
For this one, I'm wondering if up down makes more sense because you're vertically scrolling instead of like watching horizontally.
Ooh, that would be cool. True, like on the bar here on the left.
Yeah, and it as you scroll, it stays there, and you can kind of see where in the bar, like kind of a progress bar as you scroll, sort of thing.
Yeah,
but it's pinned by the chapter time and less so the screen page and stuff.
Yep. Good point.
Is your plan to add sound clips as well, or like links to those things and stuff?
Wait, what do you mean?
So like, if I go to a chapter, it'd be kind of cool to like go to that part of the podcast.
True.
So kind of the navigation like in YouTube, it would be as though if you were to horizontally scroll in YouTube to a specific part of the podcast of their video. But normally what YouTube does is like they'll have like a time series to show like when it's most popular or something like that. In your case, it might be something a little bit different, which is more around the topic, which you have a range, right? Like let's say if 2 to whatever is like that big range, you may be able to, I don't know if you can ask the LLM to kind of say like, where's like the peak of that topic getting most interesting and where is it not? But that's kind of the range of, it's kind of like segmenting it at that point, right? So people can kind of scroll to that and then say play. From there, I want to listen to what they're actually saying.
I see. Neat. Good point.
That way you don't have to show the timestamp, to be honest, right? Like if you have the visual, then the timestamp goes away.
Right. True. Yeah. Good point.
That might be too complicated though. I think maybe to start is like for that highlight that you have, just have the highlight go to that exact point of where it saw it.
The highlight quote?
Yeah, because then if you have the highlight quote, you can always, if someone can click on that and it just jumps to that part, starts playing it, they can kind of figure out if I want to go before or after or something.
Cool. Yep. Makes sense. Sweet. Anything else?
No.
Cool. Wow, you're still here? Thank you. I appreciate it. So for the next time, I'm thinking about building a laugh detector, like from a video. Because usually I feel like that's where like interesting things happen in a video. It's like if there's laughs. So yeah, let me know in the comments, what would you like to see me build next? Thanks.